I'm very happy to see so many of you today. If this is the first time with us, we are a core research facility at the University of Sydney, and we provide support to data-driven research across multiple disciplines. And among the many things we can do for you is we run training sessions like this one. So you might be surprised to hear that it can actually be very difficult to demonstrate the importance of data visualization. Some people are of the impression that plots are simply pretty pictures, while all the important information can be communicated through statistical analysis. An effective tool used to demonstrate that visualizing your data is in fact important is the Datasaurus dataset. This dataset has been modified slightly so that the means, standard deviation, and correlations remained the same to 2 decimal places. This subtle perturbation has been repeated multiple times, and you can see in the slide how this has resulted in a completely different data set and different plots. But while different in appearance, each data set still has the same summary statistics to 2 decimal places. So this is to demonstrate that you can compare data sets by mean values and variance and not look at the data at all. However, this might lead to misinterpretation of your data. An overview for today, we are going to start by talking about why you want to use data visuals, which graphs to use for your message, and how to adjust your visuals for your audience. So when we start to think about visualization for our task, we need to define why we want to use data visuals. You might want to use data visuals as a private talk between you and your data. We call this exploratory data visualization, as this is when we're trying to find insights and understand the internal structure of our data. For such visualizations, you might pay less attention to design and details. You can omit titles or not use consistent color schemes across charts, since these visualizations are only for your eyes. On the other hand, explanatory data visualizations are intended to convey information to your audience. So in this case, you need to focus more on details and the context to achieve your goal, to convey your message. Also, your decision on visualization might depend on the medium, whether you will make a live presentation or just send it on Slack or email. So let's say you're sharing a presentation like this one I'm giving you today. You can have fewer comments on charts, since you can talk about all the needed context, while in an email, it's better to provide all the details. So when choosing your visual, you shouldn't think about visualizations in isolation, but you also need to consider your primary goal and audience. There are many tools you can use for creating your visuals. When I was an academic, I spent a lot of time on Excel. I had to learn R, and the people I was working with loved to use Prism. But it doesn't really matter the tool, as before picking the tool, you will need to understand which graph you want to use. Before picking your chart, you need to know what type and size of data you're working with. So for this purpose, today we're going to use the Palmer Penguin dataset. The Palmer Penguin dataset contains size measurements for 3 penguin species observed in 3 different islands in the Palmer archipelago in Antarctica. So you can see here in this table, we have the species as a first column, and you have a nice picture here of the 3 different species, chinstrap, gento, and adelie. You have another column with the island these penguins live in, and then you have size measurements of their bill length, bill depth, flipper length, and body mass. And you have sex and the year that the data is being collected. So there are different types of data and variables. You have quantitative data, so numerical, like bill length or body mass. These data are continuous, as they can take any value between 2 numbers. Another example might be weight or temperature. And then you have discrete data. These are numerical data that, unlike continuous, has a limited number of possible values, and this includes countable, non-negative integers. So for example, the year or the number of penguins living in each island. Then you have ordinal, non-numerical data with a natural order. There are no examples in this data set of ordinal data, but let's say the penguins are swimming, you can say that they are good swimmer, very good swimmers, or not so good swimmers. And then you have categorical data, or nominal. And these are categories that don't have an order or numerical values, for example, the gender. So knowing what type of data you have will help you eliminate some chart types. In the field of data visualization, there are 4 categories of data visualization that relate to different purposes. You have comparison, composition, relationship, and distribution. Comparison visualizations allow you to examine differences between categories. And bar charts and line charts are common comparison visualizations as they show proportions and differences. Let's use the penguin dataset as an example. In this bar chart, we have the name of the island on the x-axis and the number of penguins living in each of these islands on the y-axis. And using bar charts, we can compare variables. And in this case, we can also accentuate the ranking, so the order of the variables, so that it's very easy to see that the Visco Island is the one with the highest number of penguins. Line charts, on the other hand, are very useful for time series. So if you want to look at changes over time, it highlights the trend and gives you a complete overview of the data. And using a line plot is essential because this emphasizes trends via slopes. Now this plot, I'm sorry, I've just realized that I should have had the labels a bit bigger, but we have the year on the x-axis and the body mass on the y-axis. And each penguin species has a different color. We have Adelie in blue, chinstrap in red, and Gento in black. We usually put time on the x-axis for line charts and use equal periods between data points. There is a common misunderstanding that we must make the y-axis zero-based, so it must include a 0. However, this is not true for line charts, and in some cases, these might even hinder some insights in your data. For example, here, it might seem like these 2 penguin species, the chinstrap and the Adelie, are quite similar in the variation of body weight throughout the years. But if you do this, if you change the Y limit, you can better appreciate the difference between the 2 species. So, however, this is exactly the same data set and only the Y ranges differ. So your options for time series data are not limited to line charts. Sometimes a bar chart can be a better option. In this case, for example, we don't have many data points and the bar chart is better, but this was just for giving you an idea. Composition visualizations provide insights into how individual components combine to form a whole system or data set. These visuals are ideal for understanding the proportional makeup or hierarchical structure of categorized data. And commonly used composition charts are pie charts, stacked bar chart, and stacked area charts. Pie charts are great for displaying the basic composition, but these are limited by how many parts you can display. And when categories are close in size, it's difficult to tell which is bigger and it becomes a bit hard to read. As a general rule, I would say that a pie chart should not be used if it will be divided into more than 5 parts. Stacked bar charts, like a bar chart, it compares different categories, and each bar or category can be divided into subcategories. It is useful to compare totals across categories and also to show how each subcategory forms a part of the whole. Stacked area charts are an extension of the line charts, but while the line chart is used to compare values of multiple categories over time, the stacked area chart can do the same while also showing the composition of each category to the whole. The part to the whole relationship here is indicated by filling the sections between the lines and the x-axis with different colors. And the sum of all of the areas is equal to 100. So if we go back to our data set with our penguins, the most straightforward solution would be to use a bar chart to show the share of each category. It's worth, as we did before, ordering your categories in descending order to make visualization easier to interpret. So here we have the same bar chart as before, how many penguins are living in each island, but this time we are also using colors to also show which species these penguins belong to. And we're going to talk a lot more about color later in the presentation. Relationship. These visualizations uncover relationships between variables. We have scatter plots, bubble charts, or heat maps. These are all good for examining correlations and trends between two or more numerical features. You look at this when you want to understand how changes in one variable impact another variable. You use scatter plot if you want to find out the relationship between two numerical variables. And if there is a linear relationship, a line of best fit can be added to the plot. To find out the relationship between three numerical features, the bubble chart is plotted the same way as a scatter plot for two features, while the third category will determine each plotted point size, creating bubbles of different sizes. If you have more than three numeric features in a data set, a heat map will help to determine which two features are related to each other. A heat map shows the correlation between each two features in a data set. And if you have a look at the right here, the correlation is that statistic that measures how strongly or weakly two features are related. And it is measured from -1 to +1, with 0 representing no relationship. So using, again, our penguin data set, we can plot the relationship between the flipper length and the body mass of our penguins. Each species has a different color, flipper length on the x-axis, while the body mass is on the y-axis. And we can clearly see that the longer the flipper and the higher the body mass. If we want to plot the relationship between all of the measurements that have been taken from these penguins, we will have to use a heat map. And here again, you can see that flipper length and body mass are highly positively correlated. Distribution visualizations portray the frequency distribution of values in the data set. You can use histograms, box plots, and density plots effectively to show patterns in the spread and concentration of values. And these help analyze how values cluster, and it helps to identify outliers as well. Histograms are great if you wish to communicate the distribution of the data quickly and easily to others. And this group continues numeric data into bins of fixed widths and count the number of observations in each bin. They effectively show the overall shape and clusters in a dataset distribution. Density curves are very useful when working with large sample sizes. Density plots smooth histogram bins into curves, revealing subtler patterns. At small sample sizes, that the density curves can be inaccurate to those missing gaps. Box plots are used to show distributions of numeric data values, especially when you want to compare them between multiple groups. At its core, the box plot depicts aspects of those 5-number summary. This is a set of values that describe a dataset's central tendency and spread. And these are the largest number, third quartile, median, first quartile, and smallest number. So let's say you're working with this new data set. You want to understand how your values are distributed. The first choice for frequency distribution is usually histograms. And if you want to see frequency distributions for several metrics, you can draw several histograms simultaneously. In this case, it's crucial to use normed histograms. Otherwise, you won't be able to compare distributions if the number of objects differ in groups. So for example, here I've designed an histogram to show the flipper length distribution for each of our penguin species. If you want to compare distribution across many more categories, reading many histograms on the same graph would be challenging, so you could use a box plot instead. So box plots show a bit less information and require some education for your audience, but in the case of many categories, it may be your best option. Now, this is a website that I recommend you to have a look at. So it's called From Data to Biz, and it leads you to the most appropriate graph for your data. So it links to the code to build the graph and list common problems that you should avoid. So it starts from what kind of data you have, and it lets you pick the main type of data that you want to compare using those buttons. And then you have to use this decision tree to pick a graph, essentially. And you can see that the different graphs are color-coded, depending whether you want to show a distribution, relationship, composition, or comparison. So let's say in our case, we have lots of numeric data that we want to compare. We want to compare two numeric variables. These are not ordered. We don't have many points, and this shows you what your variables might look like in your data set. And then it gives you a list of options for charts that you could pick. So let's say we pick a box plot. This gives you a kind of overview of what a box plot is, some tips and tricks on how to use it, and also it gives you the code, depending whether you code in R or Python. And if you click on the link, it will bring you to either the Python or R graph gallery. It gives you, again, an overview of the chart that you've picked, and also it gives you the code that you can use for starting your plot. So once we know which graph we want to use, we will need to adjust our visual for our specific audience. The knowledge about your audience will be very helpful in both selecting the type of data visualization you'll use, as well as deciding different aspects of the design. And when considering your audience, it's important to think about how familiar your audience is with the subject matter of your data, how much context they already have, and how much context you should supply, and how familiar they are with various methods of data visualization. This information should help inform your selection of chart type. For instance, some data visualization types are quite complex and should only be used with high-level experts in the field or people that are very familiar with data visualization. So this is an example of this. This is a set of data communicated with two different chart types. We are still working with our Penguin data set, and both these charts communicate the same variables. In the Penguin data set, we have the average build length, depth, average flipper length, and average body mass for each species. This one on the left is a radar chart. This could be a very good tool to communicate comparative data, but many audiences aren't familiar with this chart type or with the circular format in which they present the data. And as such, this kind of data may be difficult for many people to read. On the other hand, if we use a grouped bar graph to display the same data, this might be easier to be understood by a larger audience. So if you're wondering why not always opt for the simpler chart type, you're not alone. Simplicity is going to be the key, but it should also be looked at from the perspective of the bigger picture. So some chart types, while more complicated for a general audience to understand, communicate information more successfully for audiences that are familiar with them. And this is very evident in these two charts. While the radar charts are likely more difficult for a random person to read, for someone who can easily read it, it does a much better job of allowing for a comparison across the penguins. So if any of you have come from the world of psychology or linguistics, you might have come across this question before. Which one is Booba and which one is Kiki? There's quite a big consensus that Kiki is the spiky one because of the way the sound match with the shape. And this is something it was first talked about in 1929 with the notion of sound symbolism. And people are still looking into it today, as people are still trying to figure out what it is exactly that drives this phenomenon. The Booba-Kiki effect doesn't just apply to the English language and its speakers. In fact, researchers see similar results when asking participants around the world to match round or sharp-looking shapes with round or sharp-sounding words. And the illustration here is that we do have intuitive associations between sounds and visuals, and we can harness some of that in the way that we create our charts so that we can figure out what visuals we can create that resonate well with the content that they're representing. So to illustrate this, we're going to play a game. We're going to completely misuse the Palmer Penguin dataset. And I'm going to ask you to follow me on this adventure about what the Palmer penguins got up to during the Easter break. So the Palmer penguins have decided that they would run their own session of the Great Australian Bake Off. They teamed up in their own species and had a competition to see who could bake the best banana bread. So the penguins had a baking competition. They wanted to make the best banana bread, and each species was given a banana of a different level of ripeness. In this graph here, we have, as I said, the Palmer penguin dataset completely misused, but we'll pretend that the higher the bar, the yummier the cake is. So if I was to ask you which species was given the ripe banana, the underripe banana, and the overripe bananas, you would have no way of telling. So I could add a legend into here. That would be the right thing to do. But if we do this, then you already start to get an idea of which species was given the underripe bananas and which one was given the overripe bananas, or which ones got the ripe bananas. So just to check that we're all on the same page, can you type it maybe in the chat, A, B, or C, who got given the underripe bananas? Yeah, that's great. You got it. So it works. Yes, the answer is A, and that's because we associate the green color with the underripe banana. So let's say that the Adelie species, they teamed up and they decided that they were going to experiment different quantities of bananas in their mix. And each island chose a different quantity of banana. So I'm going to ask you, which island chose to include the strongest amount of green banana in their mix? And again, no way to tell this from here, right? So if I do this, and I'm going to ask you again, which island chose to include the strongest amount of green banana in their mix? Can you type in the chat, A, B, or C? Yep, you got it. So the strongest concentration of green banana is represented by the strongest amount of green color in the plot. So again, there is no legend here, but you can start to guess what's going on. Last one, so they decided to bake their cakes for different amounts of time, and here are the durations per species. If you create a plot like this, time tends to run horizontally. So if you're looking at this and you're trying to figure out which one baked it for the longest, maybe you start tilting your head a little bit. So what we can do, we can flip that round, and then you can instantly see that the gentle baked the cake for less long, the rest of them. So that's the end of the episode of the Great Penguin Bake Off, which was totally silly, but this was to show us that we can use color or orientation purposefully when we're creating our plots, so that we can engage people quickly with what's going on. There were no legends there, but you could quickly figure out which bar you should be looking at in answering the questions that I was asking. So it's worth thinking, if you were to draw your data from scratch, how would you talk about it? Or if you're talking about it and you're moving your hands while you talk, which way are you moving your hands when you're suggesting, I don't know, that something has increased in value? It's worth thinking what you naturally do and try to capture that in your plot. So color is about to make it easy for the readers to remember what is what. Your research might not be about bananas, so you can try another image or art, something that's meaningful for your own data. You can start from a photo or a piece of art and go to this website that's here, imagecolorpicker.com. This one's great because someone else has gone to the trouble of finding good color combinations. And if you like the look of a photo and the way that the colors works together in that, then you're more likely to be able to reproduce something of that in your graph. What this website allows you to do is, if you copy an image and then you go to the site, you can use your own image and you can start looking around the image and extract the colors that you want to use. But picking color is hard. At the beginning, you remember the plots I showed you about the penguins. I've used colors that are from Sydney Informatics Hub. These are our brand, guidelines. So you can use your own brand guidelines, or you can take inspiration from photos or other database or art that you like. Or you can also Google images and, banana palette or anything else. Or you can start from scratch. You can start from a color wheel and read around how best to use it. And there are a few things that we can do to adjust our charts for our audience. And I'm showing here 7 different steps. First one is we can remove clutter or noise from our charts to decrease the perceived cognitive load. So clutter is that graphical element that they place but don't give any additional understanding. Unfortunately, the default settings in our tool sometimes don't help us to make clear visualization. Each element on your chart should be your conscious decision rather than the default behavior of your tool. So in this case here, again, we are working with the penguin dataset, and this is a plot that I've made with ggplot in R. And this is a scatter plot, and I want to compare the bill depth on the x-axis with the bill length on the y-axis. Each species has a different color, and the transparency of each data point tells us how much bananas the penguins used for their cakes. So there are a few things that we can do here to remove clutter. We can increase the font, rename the axis, remove the background, and if we do that, we can see that the plot looks already much better. We have on the x-axis the baking time, and on the y-axis the yumminess this time. And we've removed that weird gray background. But again, the colors here don't really make sense. We do have a legend though, but we can give context to our colors. We use color purposefully. Just changing color of the dots, you can already make the story a bit more memorable, as we've seen before. You can basically see if we change the color, the green bananas do not make tasty cakes. That's the lesson that we're learning here. And to add more context, we have added a title and a subtitle, and this will prevent your audience questions about what exactly they see. We can also add some color to the text. And if we do this, if we add the color in our title, for example, we already start to draw the reader in and tell the story just from the title. But there's still a lot of information going on here. So we can also manipulate colors and text for adding text hierarchy. The way that you format your text influences what gets read first, what's least likely to get read, and how the readers are going to process through the information that you have provided. So have a look at this image for a minute here. What this is showing us is that there are some bits of the text that we are naturally going to gravitate to, and some bits of text that we are going to completely ignore based purely on how the text has been formatted. So when we are creating our plots, we are the ones who are in control of what's really important for the readers to have a look at first. We want to be able to control the narrative. So going back to the plot, here everything has the same attention-grabbing quality. We want a headline, and the values themselves on the axis, we can have them smaller, as that's not what we want the reader to focus on. We can change the color of the subtitle, the legend, the axis. So if we do all of this, there's just as much information as before, but it doesn't feel so overwhelming. So in here, we are jumping between the legend and the point and what it says in the subtitle and which species did what. We want to reduce the memory load for anyone looking at this plot so that the main story stands out rather than the effort of having got to grips with the story. We can add some text directly on top of our data points, where we indicate everything that was included in the legend and something from the subtitle too, so that we can better see where each species sits, the ripeness of the bananas used, and the cooking time. And we have a plot where it just sits all nicely in a place that makes it easy to read. We can highlight important data points. So it might be tempting to include all the information you have in your visualization. For example, you might want to add many labels for many data points in your graph. And at these moments, we are usually driven by good intentions. We want to give the audience comprehensive view. However, the human brain works differently. Each element you add to the visualization increases cognitive load. And by adding too many details, you risk losing your audience completely, because your charts might be perceived as more complicated than they actually are. So we want to carefully choose those things that are really necessary for sending your message to the audience. And in this case, we might highlight the best baker at the very top, the runner-up, and the worst penguin chef. So the labels, I don't know if you can really see it here, but are not very visible. The lines are compact. We want to give everything some space to breathe. So we can increase the distance between the lines, and everything then is nicely distributed. So here is our plot. We started from a basic standard ggplot package, and we ended up with something that it's much more nice to look at. So we don't really have time to cover this today, but when we talk about colors, we need to consider accessibility, and we are talking also more than just colors. We want to make sure that our plots work well for everyone. In the context of colors, though, we always worry about, just red and green. But actually, some people struggle with green, some with red, some with blue, and some with combinations of the two. So just factoring in red and green isn't really going to be enough to make sure that it works for everybody. This one in the slide is a plot from our penguin data set. We have the frequency and the bill length for each of the species. And on the right, you have 4 representations that I have created with an R package, colorblind R, that you can use to simulate color blindness in production-ready R figures. So it's a color vision deficiency simulation. This is the package in R, but I'm sure that there are other packages with Python, for example. So since we have still time, I wanted to talk a little bit about infographics as well. So data visualization and infographics are becoming more commonly used words that refer to how we learn about and share this data with others. Infographics and data visualizations are not the same thing, but they are interrelated. Data visualizations often need some accompanying storytelling in order for the data to become actionable. And this is something infographics can do well. Data visualizations can also play fantastic parts in the stories that infographics can tell. And there are a number of reasons why you might decide to include data visualizations in your infographic. Maybe you want to create an internal report, you want to use infographics in your social media, or you want to print a poster for your workplace or for a conference. So I wanted to give you some tips and tricks for some special effects for your charts. I've been mentioning solid fill colors here, but bars can get filled with all kinds of stuff, gradients, patterns, texture, or photo fills. It is very hard to get it right. It often looks clumsy, and it tends to make the chart harder to read. However, we've done this before in our baking competition plots. We have used the gradient to show the increase in the amount of green bananas used for baking banana breads. And it works. So if you're ever tempted to apply a gradient fill, first ask yourself if it is actually serving to the story. Does the fact that one color is slowly turning into another actually mean anything? Because gradients often are used to mean something, as in the heat maps, for example. So it is best to reserve them for these use cases. Another valid use case is when a light to dark gradient works metaphorically, like the green banana. Or maybe we want to represent speed or incredibly fast growth. The changing shade is technically not linked to the numbers, but it dramatizes the subject of the story. Photo fills can sometimes work, but you do have to be careful. Picture research and selection is an art in itself, as is the correct editing and placement of images. So if we go back again to our penguin data set and we have the distribution of the bill length of our 3 species, we have this histogram here, and let's say we want to add the picture of the species of the penguins in the background, and we do this, and this doesn't look great. But if we do this is already much better, and it actually helps a lot in mentally visualizing which penguin has the shorter or longer bill. Structural modifications. You can change the shape or style of your bars. Bars are one of the easiest charts to read because humans are good at comparing the sizes of rectilinear shapes. There is some research that shows that adding visual embellishments to a rectangle makes it harder to extract the underlying data point because audiences will read meaning into shapes. So let's say you round the top of a bar. Maybe you're suggesting that the value is rounded or it is an approximation. Maybe you have a triangle. This might imply an upward motion or a rapid ascent. If you decorate the top of your bar with an icon, this turns your rectangle into a pedestal or a structural support for an illustration rather than the reason for the chart's existing. So is modifying your bars helping or confusing your audience? In most cases, sticking to rectangles gives you a chart that is clearer, more accurate, and more elegant. However, in some situations, a stylized bar might be the right visual choice, perhaps because it's part of an illustration-led infographic and a standard bar would get lost in all the visual pyrotechnics or just look out of place. So sometimes altering a bar shape or adding decoration is right for the story. And since we are talking about penguins, here's an example. This is not related to the penguin dataset, but it's to show you that you can also turn the whole bar into an illustration. And once more, this only works when it's a good fit for the story, usually when the data represent objects or places like penguins, mobile phones, New York, but not concepts such as unemployment or poverty. So turning the chart into the thing itself restores the data to its native form. So converting it back into the real world phenomenon that inspired your original data set. So to summarize, how to use color and fields in bar charts. In most cases, stick to one solid color for all your bars when you're just showing one data set. If you add colors, make sure this is motivated by the story you are telling. Use color consistently. If you do need your bars to punch out more, stick to solid fill colors unless you are confident that the visual effect, such as a photo background, is narratively and aesthetically justified. In the majority of cases, your bars should simply be bars. Adding decoration is never going to make your bars easier to read or compare. So if in doubt, don't. But decoration can dramatize a story. So make sure if you do embellish a bar, it suits your topic and it's immediately understandable as a visual metaphor. But yeah, in most cases, keep your decorations as simple as possible because decorating well is very difficult. Here is a list of all of the resources that I've used for today's presentation. And that's it for me. Thank you very much for listening.